Japan has long been a global leader in transportation technology, and its innovative rail systems have been at the forefront of this advancement. The iconic bullet trains known as Shinkansen have transformed the way people travel, slashing travel times between major cities and becoming a symbol of Japan's technological prowess. However, Japan isn't resting on its laurels. In the past decade, the country has been working on the next big leap in rail technology: Maglev trains. These next-generation trains use magnetic levitation to achieve mind-boggling speeds, making the bullet trains seem like a thing of the past. This video explores the history, advancements, and challenges surrounding Japan's high-speed rail systems, with a special focus on the cutting-edge Maglev trains. The Legacy of Shinkansen, Japan's first Shinkansen line, the Tokyo Shinkansen, was introduced in 1964, revolutionizing travel between Tokyo and Osaka. At the time, the journey, which took a grueling 7 hours by conventional train, was shortened to just 4 hours. The introduction of Shinkansen trains marked a major milestone in Japan's post-war economic recovery and urbanization. By slashing travel times, the trains facilitated the exchange of goods, services, and labor across the country, helping Japan recover from the devastation of World War II. The Shinkansen quickly became a global symbol of technological advancement, setting new standards for speed, efficiency, and safety. As the years went by, Japan's high-speed rail network expanded, with the introduction of faster trains and more routes, covering over 2,900 kilometers across the country. By the 1980s, the trains could reach speeds of up to 260 kilometers per hour, and by the 1990s, they reached speeds of 320 kilometers/h. Today, Japan's Shinkansen network remains one of the most efficient and reliable rail systems in the world. The technology that powered the Shinkansen was ahead of its time. The trains were designed with aerodynamics in mind, featuring sleek, streamlined bodies that minimized air resistance. Unlike traditional trains, which are powered by a single locomotive, the Shinkansen uses multiple electric motors, allowing for a smooth and efficient ride. The tracks were also specially designed for high-speed travel, with minimal curves and gradients to ensure that the trains could maintain their speed without frequent deceleration. As a result, the Shinkansen became a crucial part of Japan's infrastructure, facilitating the movement of workers, tourists, and goods. The success of the Shinkansen also inspired other countries to develop their own high-speed rail systems, with Europe and China following Japan's lead. The rise of Maglev Technology. While the Shinkansen has remained a symbol of Japan's technological innovation, the country has always sought to push the boundaries of rail technology even further. Enter Maglev Technology, short for magnetic levitation. Maglev trains, unlike traditional trains, do not rely on wheels or tracks in the conventional sense. Instead, they use powerful magnets to levitate above the tracks, reducing friction and enabling much higher speeds. The concept of maglev trains dates back to the 1960s, but it was Japan that took the lead in modernizing this technology in the 1980s. The Central Japan Railway Company began developing maglev trains using superconducting magnets, which allow the trains to levitate higher above the tracks, further reducing friction and enabling higher speeds. This new technology was a game-changer in the world of high-speed rail. Maglev trains work by utilizing two fundamental principles of magnetism. Like poles repel each other, while opposite poles attract. By carefully controlling the polarity of the magnets, maglev trains are able to levitate above the tracks and move forward at incredible speeds. The trains can reach speeds of up to 500 kilometers/h under normal conditions. And during test runs, maglev trains have achieved world record speeds of over 600 kilometers per hour. Unlike the traditional Shinkansen, maglev trains do not rely on wheels, which means there is no friction to slow them down. This allows maglev trains to achieve much higher speeds and maintain them over longer distances. Furthermore, because maglev trains do not make physical contact with the track, they experience less wear and tear, leading to lower maintenance costs and longer lifespans. Another key advantage of maglev trains is their ability to operate in nearly all weather conditions. Traditional trains can be affected by snow, rain, and other adverse weather conditions, but maglev trains are immune to these problems because they do not rely on friction. Additionally, maglev trains are fully autonomous, controlled by the track rather than a driver, making accidents and collisions highly unlikely. The challenges facing the Maglev project. Despite the promising potential of Maglev technology, there have been significant challenges in bringing these trains to life. The first Maglev route, which will connect Tokyo and Nagoya, was initially slated to open in 2027. However, due to a series of delays, the project has been pushed back to at least 2034. A major cause of the delay has been opposition from Shizuoka Governor Haida Kawakatsu, who has successfully protested the construction of a tunnel through the region. Kawakatsu's opposition centers around the Oi River, which flows through Shizuoka Prefecture. The river plays a crucial role in the region's agriculture, particularly in the production of tea, which is a major economic driver in the area. The construction of the Maglev Tunnel threatens to disrupt the water flow in the Oi River, which could negatively impact tea production and the region's energy supply, as the river also feeds several hydroelectric dams. Although JR Central has promised to pump water back into the river to mitigate the impact, there are concerns that this will not be sufficient. Shizuoka is one of the few prefectures along the Maglev route that will not benefit from the new high-speed rail line. The prefecture does not have a Maglev station, and local residents are concerned about the impact of increased tourism on the already overcrowded region. The controversy surrounding the Oi River and the lack of benefits for Shizuoka have led to political tensions and public outcry, eventually resulting in Governor Kawakatsu's resignation in 2024. Even with Kawakatsu's removal from office, the project faces additional hurdles. The soft ground in Aichi Prefecture has caused delays in tunnel construction, pushing back the completion of the Maglev line until 2030. These setbacks highlight the challenges faced by megaprojects, especially those that involve significant infrastructure development and the coordination of various stakeholders. The future of Maglev in Japan and beyond. Despite these delays, the Maglev project remains a crucial part of Japan's future transportation infrastructure. Once completed, the Maglev line will reduce travel time between Tokyo and Nagoya to just 40 minutes, which is faster than flying between the two cities. This will be a game-changer for the Japanese economy, as it will enable faster and more efficient movement of people and goods. The Maglev project also has global implications. Japan is already a leader in high-speed rail technology, and the success of the Maglev trains could set the stage for other countries to adopt similar technology. China, for example, has already announced plans to build its own Maglev line in Hunan province, which would be the first intercity Maglev route in the country. The development of Maglev technology could spark a race between Japan and China to develop the fastest and most advanced Maglev trains. As both countries invest heavily in rail infrastructure, it is likely that other nations will follow suit, leading to a global shift toward faster and more efficient modes of transportation. However, for the time being, the Maglev-enabled future remains a distant vision. Japan's traditional bullet trains will continue to be the fastest and most efficient way to travel for the foreseeable future. But as the country pushes forward with its Maglev project, it is clear that the future of high-speed rail is on the horizon. That's all for today's video. If you enjoyed this deep dive into Japan's cutting-edge high-speed rail technology and the future of Maglev trains, make sure to hit that like button. Don't miss out on more exciting content like this. Subscribe to our channel for more tech breakdowns, futuristic insights, and groundbreaking advancements. Let us know in the comments what you think about Maglev trains and Japan's transportation revolution. Stay tuned for more, and as always, thanks for watching.